Now we're going to look at a concept called end behavior, which is what is x doing as it approaches negative infinity, which is on the left-hand side, and positive infinity, which is on the right-hand side. And when we look at end behavior, it is always written as x approaches, and we use this little arrow, as x approaches positive infinity, y approaches, and we fill that in with a blank, and as x approaches negative infinity, y approaches blank. So I really think of this as a fill-in-the-blank type of problem. Always write what I have in blue right here, and then we just fill in what y is doing. Is y going up or is y going down? So I'm going to copy that structure for this first problem. As x approaches positive infinity, what is y doing? Y approaches blank. As x approaches negative infinity, y approaches blank. And now I'm going to fill in the blanks. So as x goes to positive infinity, so the right side of my graph, y is going down forever, so down to negative infinity. As x goes to negative infinity, that's talking about my left side, what is y doing? Y is going down forever, so negative infinity. Let's look at this next one. Notice that the first thing I do is write down my structure. And now I look, as x goes to positive infinity, that's talking about the very right side. What is the right side of my graph doing? It's going up forever to positive infinity. As x goes to negative infinity, y goes to positive infinity again. Now, do you think these are always going to be the same in terms of where y is going? Let's look at the next example. Let's write our structure first. You may remember from when we did domain and range of a rational graph, which sometimes looks like this picture, that I have some other stuff going on. So in this one, I have a vertical asymptote at 1. I don't care about that because I'm talking about end behavior, and that is in the middle of my graph. So I don't care about my vertical asymptote. But as I talk about what's going on the very right and the very left, what's happening at the very right is I'm leveling off at this horizontal asymptote. And where is that? It's at 2. So the very right side is getting close to 2. And now if I look at the left side is also leveling off at 2. So it's not always going to infinities. What do you think my first step is going to be on the next problem? Writing down my structure. You know it. So as x goes to positive infinity, that's the right side, my y values are going down forever. Remember, this is a square root function, and square root functions do not have asymptotes, so I know you may get, oh, well, doesn't it look like it's leveling off? No, it's just really, really slow. Now let's look at the left side. Well, the left side as I go to infinity doesn't exist because my domain stops at -3. So what we're going to say here is DNE, which means does not exist. Next year in pre-calculus, you're going to talk about end behavior in a more formal way and use something called a limit. And so it will look like this: the limit as x approaches positive infinity, and the limit as x approaches negative infinity. So we're writing these in words right now. Next year it will be formally limits. And when we talk about limits, we talk about does not exist. So we're not going to say things like undefined or no solution. That's not what we use when we talk about end behavior. That's just kind of a picky thing. And my last example, what are we going to do first? Write down our structure. Now I can fill in the blanks. So what is the right side of my graph doing? The right side of my graph is going down to negative infinity. The left side of my graph is going up to positive infinity. Do you remember what function this is? This is a cube root function. And cube root functions do not have asymptotes. So even though, once again, this kind of looks like it's leveling off, it's actually going to a negative infinity and positive infinity for its range. It's not leveling off.